So welcome on stage, Joana.
I think it's working. Okay, thank you for the introduction. And tonight I would like to start with a question. What are the most recent natural disasters that you can remember of? Floods. Where? Greece, yes. Wait, I forgot this. And right after the fires in Greece, right? It was tragic. And what about in Luxembourg? Do you remember any disasters, Any disasters in Luxembourg? Floods as well. And something further, yes, a tornado. There was a tornado in Peiting. And yeah, it's right. And you know what? I'm living really next to that street right now. Before I wasn't, thankfully, but right now I'm living really next to that street. And it's really scary because natural catastrophes are right in the next door. And also the floods, it also happened here in Abbey Neimënster. And also at my parents' place, in Mioch. So the thing is, climate change will continue increasing if we keep consuming like we are. And also, I'm sorry, the screen is not working. Okay, it's fine. I will try this way. I will look more at this screen. Okay, thank you. If we keep commuting also the same way and consuming electricity the same way. So today I'm here to show you a possible solution against climate change. So my name is Joana FERREIRA, and today I want to tell you about solar cells. More specifically, perovskite solar cells, which are one of the new generation solar cells. And I will bring my friend Perry, that is basically the solar cell that I make all the time in the lab. Of course, it doesn't look like this. It's a piece of glass, a black glass, but it's more or less a representation. So, a conventional solar cell in our roofs. It looks more or less like this, but if we cut it in half, please don't do it, it's not safe, but if you cut it in half, you will see that there's a silicon layer that is more or less the thickness of one single hair. Now, the perovskite solar cell, it's much, much thinner. It's 200 times thinner. And the perovskite absorbs light to transform it into electricity, just like the silicon does in the conventional solar cells. Thank you. So now I want to tell you why perovskites are better other than being thinner. Well, first of all, they are easier to make. Second, they are cheaper. Also, they can transform sunlight into electricity very well. And finally, of course, my favorite one, they can have multiple colors. Look at this. So, of course, I consider them as a superhero. Now, all superheroes, wait, I forgot to tell you something. Before that, I want to tell you that silicon solar cells and perovskite solar cells, they don't need to be better than each other. Actually, they are quite the same in transforming solar energy into electricity. But they can be combined. And when they are combined, well, we can have 30% more electricity out of the same solar energy, which is great, it's awesome. So, as I was telling you, all superheroes have an enemy. Well, this one has 4 of them. One of them is air, the other rain or water, heat, and light. And it's the normal life of a solar cell. So there's rain, so rain is water, air is everywhere, heat and light come from the sun. So that's a problem that needs to be addressed. And that's where I come in. I'm trying to understand the mechanism that degrades the perovskite so that we can fix it. And to do so, I'm creating perovskites in a glove box. And that's basically a box that has controlled environment. and it doesn't have any of the 4 enemies. And then, well, this is the glove box. I wanted to show you a bit how it looks like in the lab. And then I exposed the perovskite to the different enemies one by one in a controlled way so that we can see what each enemy is actually doing to the perovskite. And so I exposed to each one of the enemies, and then I can measure it in really fancy machines. This one is giving basically the footprint. So a fresh sample would look like this, the footprint would look like this graph, what we see here. But a damaged sample, you know that it's damaged because it will have a different shape. And this one has a shoulder. Next, we have another measurement and another fancy machine. And this one gives us the topography. So just like you can see in the maps, the topography maps for the countries, the mountains and the deeps of a country. Well, I get the same for a sample, but at the nanometer scale. And that's really small. So you remember I told you about the hair and the solar cell? Well, this image is 1 micron, which means that it's 50 times smaller than a hair. It's pretty small, and I wanted to give you an idea of how small it is. So wait a minute. I brought with me a car case. So, super jumpsuit, of course. And I brought it because I wanted to ask you a question. How many times do you think that this image can be stacked on top of each other in order to make the height of the car case? Maybe let's try to do like an auction. 100 times? Hands up. 1,000. More? 5,000? 10,000? 50,000? 100,000? Well, actually, it's 50,000. Okay, now that you know more or less how small it is, I want to tell you about possible solutions for perovskites. So one of them, against water and air, well, we don't need it in contact with the solar cell, so we can just put a layer that will protect, that will protect against it. Against heat, we can cool down the perovskite. It's still fine. Now, against light, I mean, it needs to absorb light to create electricity, right? And that's something we found in our group. Actually, we can put a light filter that will remove the light that is damaging the perovskite without removing the one that is useful. And actually, the perovskite degrades much, much slower. Now, also, I want to tell you, yes, we are working on a solution, but this is research. This is slow. And these guys are my group, and they are almost all of them working on perovskites. And again, it's very slow. There's many other groups. This is just a few, really a small amount compared to all of those that are working. And still, we need time. And that's why we want to keep our street safe. This is the same street that I showed you at the beginning in Petting, but we don't need to keep repairing everything, right? So we need to be, we need to be willing to consume less. And we need to do it all together so that we can keep, so that we can keep our country safe and live happy here. And soon, I hope that Perry is coming to our roofs and help us protecting our house. Because in the end, we are not protecting the planet. We are not saving the planet. We are saving ourselves. Thank you.